Good evening, everyone. Thank you for coming. So, I, as Richard said, have spent a career in motorsport, in various forms of motorsport, culminating in a period in Formula One. But that's not what I'm here to talk to you about today. I'm here to talk to you about where this all started, for me certainly, and where this all starts for a lot of students, certainly at Oxford and at other universities. And we're going to begin with a little bit of history. So the Mercedes-Benz patent wagon, the first commercially available car, was created in 1885. And a mere 9 years after that, after having created this thing that's going to revolutionize transport, we came to the logical conclusion as a society that what we should do with this is race it. So in 1894, I think, Paris-Rouen was generally accepted to be the first motorsport event that took place. And perhaps the inevitable conclusion of the development of the automobile and of motorsport over the years was that at some point university students would get involved in this. And so it proved to be. So in 1981, students at 4 universities in America got together. They built some sort of car each. They turned up in, I think, a parking lot and went racing against each other. Not terribly successfully, I believe, but the seed was born and it has spiraled into a huge thing. Came over to these shores in 1999 when the Institute of Mechanical Engineers started Formula Student in the UK. And it has really spread into a massive worldwide phenomena. So it's in Australia, it's in South Africa, it's in South America, all of the continents, big events all around the world. These days there are multiple classes, so you can turn up to concept class, which is where you maybe haven't designed your own vehicle yet. You can design a combustion vehicle using a motorbike engine. Electric vehicle, which is what I'm going to talk about, which is what Formula Student at Oxford does, and also these days AI. So to wind back a little bit, Formula Student is students designing, building, testing, and ultimately racing. They drive it, a little single-seater racing car. We go to Silverstone, that's our big event in the summer. It takes place usually 2 weeks after the Grand Prix. And we have often over 100 teams from all around the world enter the competition. It's really huge. They fly in from everywhere. I think it was won by a team from Spain last year, from Australia the year before, from Italy the year before that. It's really, truly international. So where does Oxford come into this? So I don't know the whole history of racing at Oxford. It might be that sometime in the past before I joined, there was an attempt to run a Formula Student car. But as far as I know, around 2019, some students at the university got together in the Department of Engineering and thought it would be a great thing for us to get involved in. They managed to prove to faculty that they were serious about it and got a little bit of money, some money funded, and started to build a car. Unfortunately, COVID got in the way a little bit, and so the actual car turned up in 2022. We went racing for the first time. We've grown from about 30 students in the first year rapidly in 4 years. So I have 120 students involved in this. Mostly engineers, but not exclusively. There's important contributions from all across the university. If the physics department ever want to know where their students are, they're probably in the Formula Student lab. Computer science and mathematics as well, really popular, but also from the humanities. It's open to everybody to get involved in. And I think it's really important that we open this up and let anyone get involved, regardless of their background. This is extracurricular, right? So students build a car, single-seater race car, in a year, except it's not a year because it's 3 8-week terms. But it's not 3 8-week terms because most of those 3 8-week terms, they are studying for exams, or studying for their lectures, their tutorials, their exams, and so on. And so the fact that students can produce this in that period of time is quite frankly amazing. The graduates from it do go on to Formula One. Every year we've had graduates go into Formula One, but not exclusively that. It's just a great experience for students to take on board and go into whatever they choose to do in life, as you will see later on in this presentation. And last year we culminated in 36th overall, but as I'll get into, the overall rankings in Formula Student are perhaps beyond a bit face value. So this is the team in 2022 when we first turned up, a bit of a ragtag bunch on the straight at Silverstone. If you look closely, you will see the gaffer tape and the slightly loose electric wires in the back. Moving on a year, and some carbon fiber has made it onto the car. Someone found an old piece of Ferrari that wasn't needed anymore and repurposed it. Some little bits of aerodynamic development finding their way on there. Oxford Blue makes it onto the car the following year, and most people are now wearing team gear. And finally, we prevail, and everyone's looking smart on the straight at Silverstone. You can see the team has grown as well. So this is obviously the travelling team that goes to the event itself. Okay, quickly, the competition. It's 5 days at Silverstone. It's a long event. We spend the first 3 days going through what's called static events. So as engineers, we're always going to have to justify our designs, understand the costs, these days the sustainability, and also do a business plan presentation. And then additionally, the first 3 days are spent going through scrutineering, which strikes dread into the hearts of Formula students, participants, which is getting your car poured over every nut, bolt, line of code, piece of wire to make sure that it's safe to run. All that being well, you then turn up to the dynamic events at the weekend. This consists of a skid pad, so that's a figure of 8, fast as we can, sprint race, 1 lap, acceleration, which is a drag race in a straight line. Endurance, which is the highlight event on the Sunday, which is about 20 kilometers around a circuit. And there's also a fuel economy or efficiency section in that. The eagle-eyed among you will have spotted that I'm saying Silverstone. I've shown you a track on the map that is not Silverstone. That's because we race round a smaller circuit that's placed on Silverstone track. So it's a little bit like a go-kart track. Maybe that's underselling it. That's put up on Copse Corner, usually at Silverstone. Short straights, lots of corners, so we're not driving around the full Grand Prix track like the Formula One cars are. We have a lot of rules. Formula One has changed their regulations this year, as I'm sure a lot of you are aware, and they've made the rule book bigger. A couple of years ago, the number of pages in both the rule books was remarkably similar. The difference being, Formula Student is mostly about safety. We have a lot of rules about safety, but really open in terms of what we can do in terms of design for the vehicle. These are some examples. So there's a roll hoop there. We've got to specify steel bars, and if the car goes upside down, the driver's head won't hit the floor, etc., etc. And then scrutineering. So this is a real challenge. Student-built, particularly electric vehicles, it might not surprise you to know, are not the most 100% reliable of things. The attrition rate is quite high. I think of 120 odd teams, if maybe half of those, say 60, run electric cars, in a good year, maybe 10 of those get to actually run on the circuit and pass through scrutineering. Last year we did so. Unfortunately, we broke down in the race with a broken accelerator pedal, which was a component that was not designed by students. It was bought by students. They did fit it, however, so there is some responsibility there. And as I said, this sort of kind of strikes dread into the heart of the students. Particularly, they've often done the calculations and say confidently that the car is not going to overturn on the tilt test, and then look rather shaky as it goes up gradually on the ramp to a fairly extreme degree. We're laid out much like a motorsport organization, or perhaps any company that you're aware of. They manage this. So as faculty advisor, I'm just that. I don't tell them what to do. I just help them along the way. They manage themselves. They elect a team chief amongst themselves, technical chiefs, leaders of each of the departments, and then the sub-students work on their various sections, much as you would expect in a large company. And not forgetting business, cost, and marketing and sponsorship, which are a huge part of running the team. So now I'd like to talk about the car quickly. So this is the most impressive thing about this. This is this year's car in render form, because as we sit here speaking, the students are in the lab busy working away to put this thing together. So much so that I couldn't take a clean picture of it because there's so many people busy doing bits in there. I'd like to stress how impressive these things are as built by students. So we have 80 kilowatts by regulation from the motor. It's about 107 horsepower. It weighs 260 kilograms. So that gives it 400 odd horsepower per ton. So that's the same as a Porsche 911 GT3, a really fast Porsche. It costs about £100,000. We don't have £100,000 per year. The department kindly give us a donation towards that, but it means the students have to be very clever with what they use, how they manufacture things, what they spend, managing sponsorship deals and so on. We build it from a steel space frame, although we do have carbon fiber, which is made by the students. They do all of the layup. They understand how to design for manufacture. It runs off slick tires. It has an 8.2 kilowatt hour battery, which is built by students cell by cell. It's really impressive. They design it, they build it, they put it all together, they test it, and they ultimately run it. And we use an electric motor from Yasser. So for those of you who don't know, Yasser, great story, is an Oxford spin-out company who makes some of the world's best electric motors. They're now owned by Mercedes-Benz, and they've kindly sponsored us a unique to us Formula Student electric motor. All this means the cars are fast, but maybe not in the way you think of it. They will do about 60 miles an hour top speed, but they get there really quickly. So this will do 0 to 60 in about 2.4 seconds, which is on par with, I think, a Bugatti Veyron, or pick your hypercar. Remember, designed, built, tested, and ultimately driven by students, right? Little rocket ships. It still amazes me as to how they do this in a year. And so for this last bit of the talk, I was going to tell you about why this is good for the students and what they get out of it and so on. But I thought actually the best thing to do is let you hear from them themselves. So.
The Oxford University Racing Team is a Formula student team based at the University of Oxford, where all Oxford University students can join and have the opportunity to build a Formula student car together.
I was looking for an excuse to get into the workshop and do like real stuff with my hands, and Formula Students was one of the societies that enabled that for me.
Our engineering course gives us fantastic academic skills, research skills and engineering skills. This gives you a lot of experience as more of a workplace type experience, managing real world projects, and also a lot of soft skills, so a lot of timeline and leadership.
Just a fun way of applying what I've learned while working on an area that is interesting, which is racing and motorsports.
I wanted to kind of develop my practical skills alongside the course. You will find a solution to an engineering problem, make it up in some form of CAD, and model it and iterate on the design, and then you get to see it actually be made.
And that is a serious escape from sitting down at a desk or sitting in a library all day. It really gives you something different to do.
It's social as well, like there's a really good community.
The biggest thing is really the people. You're here to help and here to like help out with the car, help other people, and enable them to then contribute more and more to the car. So it's very much this culture that I've fallen in love with.
Knowing people from every year of your course and other courses, other colleges, you get to meet new people as part of a team of accomplishing something.
I've met a lot of engineers and material scientists and physicists through OUR. Like, I'll be walking through the department now and I'll just be stopping every so often to say hello to people. It's really nice.
I think one of the biggest benefits I have experienced being part of the team is that I learned how to apply my knowledge from theories to the practical sense.
I think it's really good to learn from the older students because these people know so much about the actual practicality of it.
I've certainly learned that you don't get everything right every time. You're going to make mistakes, you're going to fall down. I've learned a lot about what it takes to manage big projects, and that type of experience of how to fail and go again, I think is very, very valuable.
The small knowledge of like, oh, if you build a part this way, design a part this way, it'll be so much more easier to machine, so much more easier to like set up and build. Those types of insights you can only really get when you're in a workshop and you're doing it yourself. Like, oh, somebody should have designed it better. Like, I wish they did this instead of this, and then that kind of sticks, and that kind of, you can then carry that forward.
I feel it's so cool that we can actually build a functioning car from our hands, like all by the students.
Like, you're keeping different parts of your mind active, working on different things. It's just fun.
But 100% the competition is the highlight of this whole thing. It's a big challenge, you learn a lot, but when you actually get to take the car to Silverstone and compete against the other unis, you get to meet the other teams and see what they've done, that's one of the highlights of my year.
That's it. Thank you very much.